In this last video for homework packet 1.2, we're going to continue taking a look at simplifying rational expressions, but we're going to look at rational expressions that are already in factored form. So let's see what we mean by that. So what we have here is our first example of a rational equation already in factored form. What I want to do is I want to remind you of something you learned back in Algebra 1 about what it means to factor something. In the previous video, 1.2c, we took a look at factoring out a common divisor. Another form of factoring that you learned in Algebra 2 was factoring a quadratic. Now, we've got x squared plus 3x minus 10. The factoring that we're going to do, we can do because there's a 1 in front of the x squared, or just the x squared by itself. You'll remember that if you put x and x here, the numbers that go here and here must multiply to negative 10 and add to 3. Multiply to negative 10 and add to 3. You'll remember it's ax squared plus bx plus c. So it's multiply to c and add to b. Well, if you think about it, multiply to negative 10 and add to 3, I believe that's going to be a positive 5 and a negative 2. 5 times negative 2 gives me negative 10, but 5 plus negative 2 gives me the positive 3. So we went here in standard form to here in factored form. Now the reason we did that is to show you that we have already put the rational equation in factored form. Okay, we're not going to do it ourselves because you have yet to learn how to do factoring when it's a little bit more complex than a basic quadratic. So we're going to put it in factored form, but we're going to talk about why factored form is significant and how we can simplify with factored form. So taking a look at this example, what we have is we have 1, 2, 3 factors on the top, 1, 2 factors on the bottom. Now notice I'm not calling them terms. I'm not saying we have 3 terms in the top. I'm saying we have 3 factors in the top. Terms are added and subtracted together. Factors are multiplied together. So what you can see is that we have x minus 3 times x plus 2 times x minus 5. Factors are multiplied together. Same in the bottom, x minus 5 times x plus 7. What I can do though in factored form is this. Does the numerator and the denominator have anything in common that I can cancel out? And if we look at it, yes, there is something in common. The x minus 5 and the x minus 5. Both numerator and denominator have the same factor of x minus 5, top and bottom. So what am I left with? I'm left with x minus 3 times x plus 2 all over x plus 7. So that simplified it quite a bit. It got rid of that factor of x minus 5. But what we want to do, and what you'll notice the directions in the homework packet, is to make sure that the final simplified expression is in standard form, not factored form. So how do we put something from factored form into standard form? Our good old friend distribution. So let me do the distribution in the top here. X times x is x squared. X times 2 is 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. All divided by, we just have x plus 7 in the denominator. Now in that numerator, I believe there's still some simplification that can be done. We can combine like terms. I see that these two middle terms, 2x and negative 3x, are like terms. They both have an x in them. Unlike this, that's x squared. So that's not a like term. So 2x and negative 3x, I believe, makes the numerator look like x squared. 2 minus 3 is negative 1, so negative x minus 6 all over x plus 7. And here is your simplified rational expression in standard form. Let's try that again in one more example. So we've got another example here that's a little bit bigger. We actually have constant factors out front as well. unlike the previous example. However, notice that everything is still multiplied together in the numerator and denominator. So I have 1, 2, 3, 4 factors in the numerator, 1, 2, 3 factors in the denominator. So factors are things that are all multiplied together. So what can I do with a rational expression to simplify it? I can cancel out or simplify factors that are common top and bottom. So I see the x plus 6 and x plus 6 top and bottom that I'm going to cancel out. What I also see is the 4 over 14. That is a fraction that can be simplified. I believe it can be simplified to 2 over 7. So what am I left with in the numerator? I'm left with 2 times x minus 5 times x minus 3, all divided by 7 times x minus 2. Great, so we canceled out common factors in the numerator and denominator, canceled them out, but now I need to put this in standard form. And so to do that in this numerator here, first what I'm going to do is I'm going to do the distribution between the two binomials. I'm going to leave the 2 out front here, and I'm going to do this distribution. X times x is x squared. X times negative 3 is negative 3x. Negative 5 times x is negative 5x. And negative 5 times negative 3 is positive 15. And all of that's divided by 7 times x minus 2. So this numerator, there's some common denominators I can combine. The negative 3x and negative 5x I can combine. So the numerator, I have 2 times x squared minus 8x plus 15, all divided by 7 times x minus 2. So the distribution is taken care of between the two binomials here. However, to completely put it in standard form, these constants need to be distributed in as well. So 2 times x squared is 2x squared. 2 times negative 8x is negative 16x. 2 times 15 is positive 30. Divided by 7 times x is 7x. 7 times 2 is negative 14. So here is my simplified rational expression in standard form after canceling out and simplifying common factors, numerator and denominator.